So now question really is, um, what about, we looked at the idea of a decoder, right? But what about the idea of an encoder? Okay, let's look at the idea of an encoder. Okay, encoder is the opposite of a decoder, right? A decoder, if we have seen, is basically a n is to 2 power n system, right? This is a decoder. N inputs, 2 power n outputs, whereas the encoder that we are talking about is going to be a exactly the opposite, 2 power n inputs with n outputs. Okay, so this is what we want. Right, so input I0, maybe I'll call it something else because we have been using for the multiplexers inputs, so I will call it J0, J1, J, right? So this is n bit encoder. So the output here must be a y0, y1 all the way down to yn minus 1. Okay, this is what what we want. And what is the behavior? It is like this. Okay, J0, J1, J 2 power n minus 1. Okay, outputs are y0, y1, yn minus 1. Okay, now the inputs to a system, typically it is hard to control. Okay, it is hard for us to say, okay, there should be only one of them should be high, right? So the idea here is, ideally, if this is 1 and everything else is 0, right, then you want the output to be 0 0 0. So you essentially look at that n bit output and you figure out what this thing is. The 0 1 0, then you want this output to be 1, right? If it is 0 0 1 0, it will be 0 0. Okay, so again I have to write this carefully because the LSB MSB yn minus 1, yn minus 2, y0. Yeah, okay. So y1, okay, yeah, correct. So if J1 happens to be 1, then I want this to essentially become 0 1. Okay, if J2 happens to be 1, then I want this to become 1 0, stuff like that. So and you go all the way. Finally, if J2 power n minus 1 happens to be 1, then I want the output to be 1 1 1, all ones, right? This is what I want. So we can actually look at a simple 8:3 encoder. Okay, so I have J0, J1, J2, or even better, let's start with a 4:2, okay, because the number of inputs is too high here. J0, J1, J2, J3, my output is going to be 2 bits, y1, y0, 1 0 0 0, 0 1 0 0, 0 1 0, 0 0 0 1. So this is 0 0, this is 0 1, 1 0, 1 1, right? This is very this is the truth table that we really want, okay? And of course we are assuming that only one of these inputs is going to be high at a given time, okay? That need not be true, or it has to be imposed in some other way, right? For example, if J0, J1, J2, J3 are the output of a decoder, right, then it is true that only one of them will be high, right? Otherwise it's not going to be true, and therefore you need to do something else in the more general case, but I'll come to that, right? So anyway, J0, J1, J2, J3, basically I need it to be Y1, Y0 and so on, right? I need it to be like this. So what you can do now is to basically consider the case of so how is this? For example, let us look at this. So Y0, if you look at this output, right, is it becomes high, right? It becomes high only when either J1 or J3 happens to be high, right? So therefore Y0 can simply be written as J1 or J3, and on the other hand, what about Y1? It is going to be J2 or J3, right? So exactly, okay. So one implementation that you can think of is exactly this thing. You just simply put an OR gate, which is J1 and J3, you will get Y0, J2 and J3 is Y1, right? So if such a it seems a very simple straightforward implementation of two OR gates, you just put that in and you should be able to get what Y0, Y1 and all that stuff is, right? Now this can be extended even to a 8:3 encoder, right? You just have to have 8 inputs, and depending on the input combination. So let's just maybe write that down: J0, J1, J2, J3, J4, J5, J6, J7, Y2, Y1 and Y0. Okay, so if this is 1 0 0 0 0, then we are talking of 0 0 0 0 1 0 0 0 0 1 1, right? We are talking of 0 1 0, then we are talking of 1 0 0, 1 0 1, 1 1 0, and finally 1 1 1, right? So now the question is Y0 in this case, right? If you again look at just Y0, it goes high if the even inputs, that is J1, J3, J5, J7, if any one of them is high, right? And therefore, sorry, I just have to say that J4, sorry, J1 plus J3 plus J5 plus J7. Y1 is basically going high if you have J2, J4 or J6, J7. J7 and Y2 is going to be one of J4 plus J6 plus J7, right? Yeah, so again with a simple 4 input OR gate, you should be able to handle this encoding scheme, right? Now what happens, so it's very clear if, so this is a very simple implementation because we have said that, the inputs J0 to J7 have to follow a certain pattern. That is, only one of the inputs can be high at any given time. If that is not true, then all this will break down and you have to look at a more complex expression for this whole thing. Okay, so let us look at that in case of a, and that is known as a priority encoder. Okay, so let's look at the difference between an simple encoder and a 4:2 priority Now we are not going to impose any condition on the input. The inputs can take any arbitrary value, but the output should basically prioritize one over the other. Okay, so let us look at this. So I will say J3, J2, J1, J0 are my 4 inputs. My outputs will be Y1 and Y0. Okay, so this now, because I am going to consider all possible combinations, I can just write out the truth table and actually solve for the K-map appropriately. Right, so I have, yeah, so let me just make a copy of this. No. 1 0 1 0 1 1 0 0 1 1 1. Right, again let me make this. Okay, yes, so now I am going to simply replace this with all ones. 8, yeah. Okay, so now what we are going to do in this priority encoder is, whenever there is a clash, let's say more than one input happens to be high, right, we are going to say that the output will get prioritized to, let's say, the lower number input. Okay, that could be the case, or it could be higher number also, right, in any case. So we are going to say priority to lower number input. Okay, so if it is 0, if it is all zeros, okay, then I'm going to say the output is 0 0, because I can't differentiate between 0 zeros and J0 alone going high. So I'm going to say this is what I want. Okay, when J1 goes high, yes, this is what I want. Now there is a clash between or I will say lower to higher. Okay, now in this input there is a clash. So whenever there is more than one input going high, there is a clash, right? And therefore we have to prioritize. Okay, so we are going to say that one of these we are going to prioritize the higher number input, that is J1. So therefore this will continue to be 0 1. Okay, now we are coming to 2, so this will become 1 0, and now again 1 0 1, J2 is high, J0 does not matter, so the output is 0 1 0 like this. Then we are saying again J2 J1 is high in this case, right? And therefore it doesn't matter, it's still this. Now J2 J1 J0 is high in this case, still it doesn't matter, we are saying this is the output. Then we come to J3, right? J3 has gone high and therefore this is the output, and of course after this nothing matters, because any particular output we are basically going to do the, it doesn't matter what the state of J2, J1, J0 is. Once J3 has gone high, the priority output is going to be exactly this, right? Now what you can do is to solve for Y0 and Y1 in terms of the truth table, right? In terms of the K map that we have. Okay, so this is J1, J0, J3, J2. So this is J1 bar, J0 bar, J1 bar, J0, J1, J0, J1, J0 bar, right? And this again is going to become J3 bar, J2 bar, 3 bar, J2, J3, J2 and J3, J2 bar. Okay, 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. Okay, so now I will make a copy of this because I need it to solve Y1 also, right? And therefore I can now, so let me look at the case of Y0 here. Okay, we are looking at Y0. So it is 0, 1, 2 and 3, right? 4, 5, 6, 7, from 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 8, 9, 10, 11, 12, 13, 14, 15. All of this is going to simply be a 1, and therefore I can simplify this, right? So my Y0, maybe I should do that in a different color, right? Is essentially it does not depend on J1 or J0, right? And J2 also does not matter, and therefore I am saying Y0 is just J3, right? J3 due to the first simplification, and of course I have a second simplification which is like this, right? So therefore I'll write this in, I'll color code correctly, J3 plus, in blue what I have is J0 doesn't matter, I have J1 here, and in this case it is J1. J. This is my implementation for a priority encoder on Y0. Okay. Likewise, I can also do the same thing for Y1. What is Y1? It is 0, 1, 2, 3. After that, everything is 1. Okay. So now I am saying for Y1, 0, 1, 2, 3 is all zeros. Everything is 1 after that. Okay. So I can do 2 groupings in groups of 8. Right. Therefore, Y1 will be equal to, in magenta, I get J3 and yes, right, plus in blue I will get J2, right, because J3 is changing there and I will get J2, right. So effectively if you do this, right, so let me just write them together. Y0 is J3 plus J3 J1. Y0 is equal to J3 plus, in blue it was J1. Okay. So this again is a very simple, straightforward implementation for the outputs Y0 and Y1, right? And like I mentioned here, this is very advantageous because we are not putting a constraint on the input. Okay, we find that the output is the priority encoder takes care of any input combination and ensures that the output is suitably high and produces that necessary output as needed, right? So with that, I'll wind up this discussion on the general encoder, decoder, multiplexer, demultiplexer that we have done over the last few lectures. Thank you.